Welcome back. In this lesson, we'll look at the use of parameters and returned values with functions and procedures. We'll use the example program of a game with a fox and a hen that you created last week. In this lesson, we'll look at how values are passed between the main program and functions or procedures. We'll look at the use of local values, global values, and returning values. To recap where we already are, in the last lesson you created a simple procedure called show place and called the procedure in the main program. Here's the definition and here's where the procedure is called. This procedure always does the same thing every time. It displays the position of the 4 characters in the game, if I can call the corner character. So in this lesson, the first thing we're going to do is to create procedures to check whether you have won or lost the game. If all 4 characters are on the right side of the river, in other words, if they all have the value true, then you have won the game and the one variable is set to true. If the fox and hen are together and you are not there, then the fox eats the hen. And if the hen and the corn are together and you are not there, then the hen eats the corn. And in either of those cases, you've lost. Okay, so I want to take this code out of my main program and pop it into a couple of procedures. Simple, right? So here I've done it. I've created 2 procedures called check win and check lose, and I've simply copied the code out of the main program. But if I run my program, these procedures don't work. The program won't check correctly whether you've lost or won the game. So why not? To understand that, we're going to have to look at the memory of the computer. When you run a computer program, the computer allocates an area of memory for all the work of the program. All the variables used in the program have their own area of memory inside the main program's memory area. When you run a procedure, a new area of memory opens. This area of memory is only open for as long as the procedure is running. The procedure can see the values in the main program, but it can't change these values. So when those 2 procedures that we just looked at created new values for the won variable and the lost variable, those were new variables inside the temporary memory of the procedure, and it did not change the values in the main program. The name for these variables that occur entirely within a procedure is a local variable. So local variables are lost when the procedure closes down and they don't affect the main program. An alternative to using local variables is to use global variables. If you have global variables, then your procedures are allowed to overwrite the values in the main program. In fact, the procedure could overwrite the variable multiple times as it is running. And in fact, although I'm not showing it on this diagram, other procedures could step in and start overwriting those global variables as well. I'll have another whole lesson on this topic next week, but for now just take it from me that this is quite a risky way of writing your programs, and it's quite easy for things to go wrong. However, if we do decide to use this method, we do it in Python by writing inside the procedure that we want to treat the variables as global. So here I've set the variable 1 that says whether you've won the game or not as global. And that means that when that value of 1 is set to true, this will overwrite the value of the one variable in the main program. And I've done the same thing with the variable lost in the check lose procedure. So this does work, and I urge you to try it because it's a good way to explore the use of global variables. But in general, I try to avoid the use of global variables, and it's generally seen as bad practice in programming. So although it will work, let's avoid it and let's look for a different way of solving this problem. An alternative to using global variables is to use a returned value. A returned value means that a variable exists in the memory of a function, and then when the function is finished, the variable is passed down to the main program and the function disappears from memory. You're only allowed to make one change, and it can only happen at the end of the function, just before it disappears from memory. And the returned value must be captured by a variable in the main program. And did you notice that if a procedure returns a value to the main program, we don't call it a procedure, we call it a function. So let's see how we'd make that happen in our code. Here are the two functions which we wrote before, but now I'm returning the value of win. In fact, I'm returning two different values, but only one of those will be carried out. If the win condition is true, then the value true will be returned. Otherwise, the value false will be returned. Notice I don't need to use else, because if the win condition is true and the value true is returned to the main program, then the function will close down in memory, and I'll only get onto that final line if the first condition hasn't been true. So it's just a little thing, but you don't need to use else when you're using a function like this. Okay, and then also we've got to capture the returned values. So check win returns the value of the one variable, and check lose returns the value of the lost variable. So I have to assign that returned value to the correct variable. And remember, this is something we've done way back. Variable equals value is the structure of variable assignment. So the name of the variable, then an equal sign, and then the value that we want to assign to that variable. And in this instance, the value that we want to assign to the variable is the value returned by the function. So let's see what the program looks like so far. We've created a procedure called showPlace, and now we've also created functions called checkWin and checklose. And checkWin and checklose return either true or false to the main program, depending on whether the win or lose conditions have been met. And here's the main program. If you look at the bottom two lines of the program, we call those procedures and we assign the returned values to suitable variables. Well, let's have a look at what's left of the main program. Does it offer us more opportunities for decomposition? Remember, decomposition means breaking the program down into smaller blocks. These three parts of the main program are very similar but not identical blocks of code. And now we're going to see how we can create one function to meet all three of those requirements and use parameters to make them work in slightly different ways each time that block of code is called. So parameters are values that are sent up from the main program to a function or procedure, and they are caught by parameter names inside the function or procedure. Notice that the variables or values that are sent to the function need not have the same name as the parameters in the function itself. And the effect of these parameters is to change what the function or procedure does. So let's have a look at that in action. The procedure is called change, and it changes the place of any of the objects in the program. The two parameters are called the place and the name, and both of those values are used in the function. If we call the function, we can call it with different combinations of places and names. So I call it with the place of the fox and the word fox, and those two values will be passed up. Fox place will be captured by the parameter called place, and the word fox will be captured by the parameter called name. Notice that there must be the same number of parameters, and they must be in the same order as the parameters in the procedure or function. And having done that, we can call the procedure again with the hen place and the word hen, or the corn place and the word corn. So we write the function once, but we call it 3 times with different parameters. We also want our function to permanently change the place of these different characters in the main program. So let's use the example of fox place. The fox's place is sent up as a parameter. It's changed in the main program, and the new different value is passed back to the main program, and now it's permanently changed. So we're passing a parameter up, we're changing it, we're sending one returned value back, and that is captured in the main program. So in this instance, we're returning the place of the fox, either a different place or the same place, depending on whether we've managed to bring the fox across the river or not. And in the main program, we're recapturing those returned values as a new value for fox place, hen place, or corn place. So this is our main program now. It's a lot neater and shorter than the one that we began this lesson with. We're calling the show place procedure, the change procedure, and the check win and check lose procedures. The program's shorter. It's less coding because we've reused some of the functions more than once. And I think that program is a lot easier to read than what we began with. So in this lesson, we have looked at the difference between local and global variables. We've learned what parameters and returned values are. And we've looked at what's happening inside computer memory when we use these different types of values. Your next steps are to make sure that you've got good revision notes on these different technical concepts. And to work on the fox and hen program, you can do this by copying what you've seen today, or by closing this lesson and trying to do it on your own. In the next lesson, we're going to do the same kind of thing again with a different game called Gorgatron. So this is because it's quite a lot to remember, and going over it another time will help to get it clear in your mind. Okay, so I'll see you next lesson when we'll do the Gorgatron challenge.